Today, I will explain and give hands-on practice of what really is correlation in machine learning. So, you guys heard about correlation many times. Like, what exactly is correlation? So, correlation basically states as the relation between the entities, such as features and labels, or also between features to features. So, here, how can we use correlation in our machine learning? And how can it help us to relate the data between the entities? So there are three types of correlation basically. So first is positive correlation, second is negative correlation, and third is no correlation. So if suppose on x-axis there are some features, like for example we suppose here the feature is only one, and is on y-axis there is label. So if the relation between these two entities is positive, like directly proportional, then the graph will be positive linear. And if the relation between those two entities is negative, means they are inversely proportional. So the graph between those two entities will be negative. And if there is no relation, like the data is so noisy, so there will be no relation by linear regression. So this will not be useful in linear regression. And let me show you the hands-on practice on this. So here is the code. For this, I am using Kaggle.com, where you can create your own notebook and works on it. So here I imported two libraries, as first pandas and second is matplotlib pyplot plt. So the first library is pandas. I am using here to differentiate the data and store the data in SQL format, like SQL tables format, to visualize them and to fetch them easily. And the second library I'm using is matplotlib. So matplotlib is used to plot a graph is to plot a graph between those two entities. So here is the data which we have. Then then I will use pandas library here to fetch those data and store it in DF. DF is like data format. For example, here we suppose that DF variable. Then I will use PLT means matplotlib library. So by PLT library, we can scatter those data. Like here, I am using experience and salary. Those are two entities which I am using. Experience, experience is feature and salary is label. So here you can see I am using the PLT library to scatter the data, and the data I am using is from DF. First is experience, second is salary. Then I will plot experience on x-axis cause its feature, of course. And the second one, salary, I will plot is on y-axis cause we need to search for this and we need to predict that data. So I will be using here y is equal to mx plus c formula as well, where y will be our label and we need to predict that by using our experience or our feature data. So by doing this, we can see the graph is positively plotted. Means those both are in positive relationship, where in increase in experience, the salary will also increase. And here I am also using the second example, where I am using shoe size as feature data. So you can see here between shoe size and salary there is no relation. Look here, there is no relation at all. So the data is more scattered and the data is more noisy. So linear regression will not use this data and there will be no use of this data even. So let me just change the data of shoe size to its inversely proportional. So you can see the hands-on practice as well. So first, look, after running that, what we will get the negative relation between those two entities, where the graph is inversely proportional. Means increasing in shoe size will decrease the salary remarkably. So here the relation is negative, and we can plot the graph using this. Means linear regression will use both two data, positive and negative. But it didn't use the third data. Let me show you that as well. Oh, sorry, my bad. Didn't use another data. Look here, you can see the data is more scattered, so linear regression will not use this data. So yes, this is all about relationship between those entities, and find you can find the relation and you can create the data as well from this. So this is for today. Bye.